Okay, so in 10.4, we're going to continue talking about hypothesis tests with tables. Here we're going to be looking at a one-way Anova, and this one is comparing various means. So you have samples, groups more than two, and we're going to be looking at means. And so what we're trying to look at is, is there a big variation within the means? So this illustration kind of shows that nice here, where you see here we have all means where they're slightly different, but are those gaps or differences large enough? That's really what we're interested in. And we're not checking that they're all different, but as long as at least two of the groups don't have one, so as long as one is far away enough from all the others, then we're going to say that as long as one of them veers far away enough from the other means, then we say that they're not equal in that case. And this is going to be dealing with an F distribution. Again, not normal, skewed to the right slightly. The larger the sample size, then it will also end up looking a bit more normal or so. Okay, so here let's look at an example. And so we're looking at 3 different diet plans are to be tested for mean weight loss. And again, there's a key phrase, mean. The entries in the table are the weight losses for the different plans. The one-way Anova results are shown in this table here. Okay, so so this is going to be our the values that we end up getting here. And again, the key word is that we're looking at means. And so I'm going to change this a little bit from example 1010. I'm going to kind of go the other way. So let's run an Anova test to see if there is no difference. So we're going to actually check that there is no difference. So that means the null ends up being our claim. And if we're seeing that there's no difference, we're pretty much saying that all of the means are going to be equal to one another. Okay. And then the alternative is going to be that at least 2 of the means are not equal. And so for the null, you could typically write it in words, or you could go ahead and use some of the notation where you set all means equal to one another. But this time around, the null is going to be our claim. If we go to our second step here, really all we're going to do is run a 1var stats on all 3 of these. So we're kind of use 3 different lists. And we'll go ahead and report that information. And so before we actually get into the third step, is one thing to look at is here the values of the means. And so again, we know they're not exactly the same, but is one far enough or is one different enough, right, than the others that it makes a big difference, just statistically significant. So we know it's right-tailed. It's going to be skewed to the right here. So it's always going to be a right-tailed because we're checking if it's equal, not equal in this case. So if they're, but at least one of them. So just like the goodness of fit, so it's always going to be right-tailed here, but we're using an F distribution. And so there's our alpha, and that line in the sand right here corresponds to our F critical value. So these are the values that we're typically interested in. And if we plug this into our calculator, and I'll show you how to run that on the next slide, we find out our p-value is 0.6991, and then our F test statistic is about 0.38. And so the question is, where exactly does that lie at? So we're going to compare it to alpha. And so we see that that p-value is larger than alpha. So alpha is going to be contained within there. So our F test statistic would be somewhere perhaps around here or so. Okay. And so now we could go ahead and do our comparisons. P-value is greater than alpha, so do not reject the null, reject the alternative. And this time around, the claim was the null, so whatever decision we made for the null, we'll make for the claim. So don't reject the claim. And since the null is the claim, we're not allowed to use language like support or do not support. So we got to use that warrant or rejection. So we're going to say there is not sufficient evidence to warrant a rejection of the claim that not all plant way means are equal. And again, it sounds kind of like that double negative, but it's just kind of the way of writing the statistics. We don't want to really say that we support it in this case here. So similar to the other tests, our 4 steps here are really is step 1, writing it out slightly different to null and alternative. And then in step 2, we're really going to calculate those 1 var stats for everything. Not completely necessary to run the test, but it is helpful because if we've seen that it went the other way around where, one of the means did look different, then we could further inspect and see which one of them looks like the one that would stick out the furthest. And so here is how to manually calculate some of these things here. So the S between and the total to get that your F test statistic if we wanted to go ahead and work that out by hand. So getting the betweens, the totals, and you could go ahead and pause this if you want to look through them. But let me go to this table here where this is a bit summarized. So here's those calculations in a nice table that's summarized there. And again, the test statistic here being the ratio of the MS factor and the MS error in this case here. And if you run this on the calculator, you're going to put all the data into 3 different lists, and then you run an Anova using all 3 lists, list 1, list 2, and list 3 there. And it's going to go ahead and give us all of that. So it'll give us the test statistic there that we want, but it will also give you some of these other values that we want. So the MS factor is going to be here. That's the 1.12. And then I'll give you the MS error, which is going to be over here. Okay, here's another example here. So if you want to pause it, go ahead and give it a go, and then I'll kind of comment on this a bit. Okay, so again, we know we're looking at means, and we have more than 2 groups. So this is going to end up being an Anova. And this time around, we're saying that there is a difference here. So then the alternative ends up being our claim. Our second step, again, just putting everything into list and then doing a 1 var stats 4 different times for each of the data sets there. And this step is helpful because we could compare the means. And again, if we find out that there is a difference, we could see which one of these stands out as being a lot larger, right, or a lot smaller than the others. And so here's our F distribution, again, skewed to the right here. And it's going to be right-tailed here. There's our alpha. And when we run this on the calculator, we get our p-value and then our F-test statistic there. So p-value of 0.1241, F-test statistic of 2.23. And again, comparing your p-value with your alpha, the p-value is larger. So once again, alpha is contained within that within the p-value. And so we could go ahead and say p-value is greater than alpha, so do not reject the null, reject the alternative, and this time we'll reject the claim because that was the alternative. Since the claim is the alternative, we are allowed to use language like support. So there is not sufficient evidence to support the claim that not all means are equal.